Hi guys, in today's video we're going to take a look at Hess's law, enthalpy cycles using the enthalpy change of combustion and the enthalpy change of formation, an exam style question, and finally a summary.
Hess's law was proposed by Germain Hess, a chemist and a doctor. Hess's law states that the enthalpy change of a reaction is independent of the route that is taken. So if we have this reaction here, where A plus B is going to form C, if we call the reaction that forms A plus B forming C delta H1, then we have delta H2, and this is the reaction of A plus B to form D. If we have delta H3 as the formation of C from D, this arrow here, delta H3. According to Hess's law, delta H1 is equal to delta H2 plus delta H3. So whether we take a direct route from A plus B to C, or a route that's a bit more convoluted from A plus B to D and from D to C, the enthalpy change of the reaction will be the same. So this triangle that we have here is what we call an enthalpy cycle. Let's take a closer look at enthalpy cycles now so we can see how to construct them. The enthalpy change of a reaction cannot always be directly measured. So we can use these enthalpy cycles to help us indirectly calculate the enthalpy change. So let's take a closer look at an enthalpy cycle. Well, an enthalpy cycle is a pictorial representation showing the alternative routes of reaction between our reactants and our products. So here you can see we have our reactants and our products. Down here we have certain elements. So let's take a closer look. Our enthalpy cycles, as I'm sure you can see, are triangular. In each corner there should be the same number of each atom. As well as energy, matter is also conserved, so the same atoms will be in our reactants as in our products. The sides of our triangle are arrows and they show the direction of the reaction. And from this enthalpy cycle we can see that A is equal to B plus C. The enthalpy change as we move from the reactants to the products is the same as the enthalpy change as we move from the reactants to the elements below to the products. So let's have a look at some examples of some enthalpy cycles to understand what exactly is going on. We're going to start by looking at enthalpy cycles that utilise the enthalpy change of combustion. We can use these enthalpy changes of combustion to find the enthalpy change of the reaction. And the reaction we're going to take a look at is the formation of benzene from carbon and hydrogen. Well, carbon and hydrogen can be combusted to form carbon dioxide and water. Now, whilst the reactants can be combusted to form carbon dioxide and water, so can our product, benzene. It too forms carbon dioxide and water when combusted. So if we were to construct an enthalpy cycle, it would look something like this.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.